Are you able to work through this one?
I'm still working on it.
Okay, great.
So I need to come up with a common denominator for all those.
Say that one more time.
You have to come up with a common denominator for all those.
You do, and the answers can maybe help you. That if you always should scan the answers. Like 30 is a good choice for them.
Then you would multiply by 10, so 20 by 15, 30, 6, which is 12. And then it's the reciprocal of that, right? So it'd be
Yes.
C.
Say that one more time.
C?
Yes. Okay. So a lot of fractions there. This is not a calculator problem. It's designed to, see how comfortable you are with fractions.
Is there a shortcut? Because the fractions take me a long time.
I call it number sense. It's the ability to go from line 1 to say line 2 without writing anything, or line 3 without writing anything down. That would be, and we could work on that if you wanted, but that's really a skill here. It's holding steps. Like this is -3/2. The negatives cancel, and then you flip it because it's 1/, and that's how it becomes 2/3.
Right. Okay.
And then other than that, you want to be able to maybe write. So if you could write this, you really do have to go to common denominators. If you could go to like this step here, because you combine them mentally and then you flip it, that would be a good one to do. But that's the only time savings here is your ability to do that. But do you want to do another one like this, or do you want to move on to a new question?
Let's do one more like it if you have it.
Okay, let me give me a moment here to get there. Okay, so this one is a little bit harder, but it's got the same sort of emphasis on fractions. Let me get the right width. Okay, snipping this in. So let me try to diagram what I'm asking you to do, and then maybe I'll give you another one here to do that, because I want to make it clear that the steps, what the steps are here. So even better would be if you can say, okay, this first one here, I'm going to put -2/5 in for k.
Right.
Okay, so this is the think step, and this is what you're actually going to write. So you're thinking -1/3 times -2/5. Like you noted, or that's what you want to write. But what I really want you to write is say, okay, well, that's -6/5, and then the two negatives cancel. It's really 1/6/5, so it's really 5/6. And that's how you save time here. So the next one is 1/2 times -2/5. So that's 2 times -2/5. That's -4/5. The negative there makes it positive, so it's +4/5. And then I flip it, so that's 5/4. And then the last one is -1. So say that again.
You just do it all in one step instead of.
Yeah, it's like you see it and you write like I'm writing it up here, but I don't want you to. I want you to, it's -8/5. I have a negative up there. It's 8/5. Flip it. That's 5/8.
Right. Okay.
Now your common denominator here looks like it's 24. So instead of writing it out 3 times, you write out 1 time. So that's 6 times 4. So it's 5 times 4. That's 20. 4 times 6. So 5 times 6 is 30. That's times 3. So that's 15 times 3. That's 15. So now I'm going to add these up. That's 65. Rather than writing 65, because I know this equals A, I want to flip it. So it's 24/65 equals 1/A. The more you can, I don't know if this is the right word, think right, but it's the step you're holding in memory. So let me give you one more here, and let me not pick crazy numbers, but at least give you a shot here of trying to do it on your own. Okay, so here's one. Give that a try, please.
I got D -2. Oh no wait, sorry, it's a reciprocal, so it would be oh well, wouldn't be any of those. So that means I got it wrong. Or no, would it be C?
I don't. Do you have an answer? I can tell you if it's correct or not.
Okay, let's go with C.
Okay, it looks like it's B. So let me just. Did you get this line on the right here from mental holding the numbers in and then flipping them?
Oh, I think I forgot to flip them. That's probably why, because I got I got 1, but then I got like -5/4. So.
Yeah, so it is 5/4, but then you flip it because it's 1 over.
Oh, that's my issue. Okay. Okay, let me start from there then.
So this is another example of that. Like, you know that this is -3, but you also know that you're going to have to write it with a bottom of 5. So if you can go from -3 to a bottom of 5 without writing anything besides that, that's how you collect all this extra time on questions like this.
I'll try.
And that's why I thought because you said B initially, and I thought you had
Oh,
gotten.
I said D.
Oh, okay.
Yeah. Which they're smart. They put that because if you don't flip it, you would get the right answer. But
Yeah. Like, this last step is completely unnecessary to write down because you're not giving your answer to someone to read. You're giving it to a computer. Once you know the answer, you go and circle it and you're done. You don't take the time writing it. So that's what I'm trying to emphasize here with this. So do you want to do one more or move back to that practice test?
if you have one more,
I have hundreds, so we can do as many as you want. But I mean, at some point, I'll recommend hard that.
I just want to get like one.
I want you to be able to do it too. I'll I'm trying to pick ones that aren't crazy. I mean, you're not going to get this question. I mean, the SAT College Board didn't ask me to write any questions, but someone who writes questions will write something with this technique in there, and that's what you're preparing for.
What's common denominator? 15 and 9.
So it's always good to look at the answers. Sometimes they're going to have that in there.
40, 45.
45, yeah. And if you can write it one time rather than 3 times.
So that's 3 times 3 is 6 times 5 times 5 is 10. Oops. Okay, so then that's 119, 45 over. Oh, what did I do wrong? see the answer choices?
Are you able to see my screen?
Yeah.
Okay.
Oh wait, are those?
Oh, I'm sorry. I scrolled up. My apologies. Right there. Yep, it's in here.
I still did something wrong. Hold on, I need to check. Why does negative 1/3 not flip to become -3/1?
So you're talking about the first one there.
Yeah.
It's -1/2 times 3/2. The 2's cancel, leaving that 3 on the bottom.
Right, but don't you have to flip it then, like all the other ones?
You flip it when there's a fraction. So like if it's 1/a/b, this equals b/a. In the example here, what you're asking about is like, what is it when it's 1/a/1? Well, if we go back, we just multiply the top and bottom by the reciprocal. The bottom becomes a/a, which is 1. The top is really 1/1 times 1/a, which becomes 1/a. Anything over 1 is itself. So that's why it only flips if there's a fraction on the bottom.
Okay.
It only flips when there's a fraction on the bottom.
So then it would be 1/45. Oh, well, yeah, 1/40. No, but then you would do, so it would be b.
Yeah, it is b. So maybe let me just summarize here a few things. Like 1/1/3 is the flip of this fraction, which is 3. The flip of that is 3. 1/2 is the flip of this bottom fraction, which is 3/2. But 1/3 is 1/3. So you only flip here when it's a fraction.
Okay.
And it's totally possible to get it or not get it to flip. Let's move on to another question here.
Yeah.
So we took a little more time on that one. Let's go to 3 here. This is a graph question. Okay, which of the following is the correct equation of the line containing points H and I? So if you look at these equations, these are in a point slope form. Same thing, and then standard form.
Mm-hmm.
And sometimes it's good to look about what's the same, what's different. Well, what's the same about these two is they have the same slope. So probably the first thing I do is find the slope between the points. There's 2 ways to do that. You can literally just count, rise over run, or you can use the slope formula. And frankly, it's going to be one of, it's probably going to be one of these answers here. Like, you shouldn't be surprised when you see it. That's why it's always good to scan the answers as well when you're
It's probably faster to do the slope. I mean, just to count.
Yeah.
1, 2, 3, 4.
So 4.
10.
Yep.
So 2/5.
Yep, 2/5. So that means it's that one is out, but this one still could be in. We don't know yet. Okay, so now point slope, because it's saying which of the following, means you got to look at the answers. If it's going through point H, this is the order pair -7, -4. And this is the ordered pair 3, 8. So if you don't recall, point slope is y minus y1 equals slope x minus x1. Your x1 and y1 come from one of these ordered pairs here.
So you can choose either one, right?
Say that one more time.
You can choose either one, either point.
Yeah, but because the way the answers are given, you almost have to like decide is B correct with this point, and is A correct with this point.
Okay.
And it's not as simple as me just saying like, hey, you know, like I don't want to just tell you. I want you to kind of decide that here for me. Tell me if X1 and Y1s are in the right place.
So by minus 8 equals 2/5 times x minus 3. Nope. So it's the other one. It's A.
So A would be Y minus -4 equals your slope, which you already told me, 2/5 X minus
Oh, but
-7.
it would have to be plus.
This is
For
Y
the,
plus 4. Yeah, 2/5 X plus 7. So it's only partially right.
the D is also in there.
So probably is D. Like it's probably D. This is a good. I mean, this is a great like question because if you don't even have to know how to do it, you just have to know that that's wrong, wrong, wrong. So that must be right. And you don't have to verify that it's right. You just have to verify that the other three are wrong, which you've done.
Mm.
So let's do another one here where you work through this again. I can't guarantee that the answers will be the same. Where it's like, oh, the standard form one is right. That's not necessarily going to be true. But let me pull it up here. All right, snipping that in now.
So it's 1, 2, 3, 4. 1, 2, 7, 8, 9, 10. Okay. So 4, 10. Comma 2 and 7, -2. And it's D.
Okay, let me just confirm that here. So it's letter D. Question 3. Yep, that's right. Okay. Do you want another one like this? Do you want?
No, I'm good on this.
I'm sorry.
I think I'm fine on this.
Okay. Are you comfortable moving between point slope form to standard form?
I think so, but maybe if you want.
Yeah, let me give you one here. So let's say it's y minus, we'll just use those 5/2 x minus 7. How would you convert this to standard form? And recall, so standard form is ax plus by equals c, but a has to be positive, a comma b comma c, they all have to be integers.
Right.
So you could distribute, you could clear the 2, like it's totally up to you, but let's go ahead and work through that. I'm going to multiply everything by 2 just to start out. That would be my
And then do 2y. Wait, why didn't you multiply the 2 to the, you don't multiply it to the x minus 7?
Yeah, I was going to bring that up because a lot of this is one term here. They're all combined. It's like saying A times B times 2.
Okay.
And if that doesn't feel good, like imagine this. When you multiply in, you're not doing it to both. There's one thing inside here. There's one term is what it's called. That's better in my opinion than distributing the 5 halves, because then you get 2 terms. But if you think you're going to forget, do it the way you think will best work for you.
So it should be 5x minus 2y. Okay. That's fine.
Okay, so let's move to a new question. This is not none of these are calculator questions, and we've kind of dialogued about that, but these numbers are reasonable to do without a calculator. It's a story problem. It's the first one you've seen. So let's take a look here. So the cost of starting a kiwi crop in North Carolina includes a fixed cost of $10,000 and an operational cost of $8,000 per year. The cost of starting a lettuce crop in Wisconsin includes the startup cost of $2,000 and a variable cost of $4,000 per year. Gabriella has always wanted to try her hand at farming and just received an inheritance of $120,000 from her cousin Ken. How much more money will Gabriella need in addition to her inheritance to operate both the kiwi farm in North Carolina and the lettuce farm in Wisconsin for the next 13 years? So could you, like, is it, what's clear to you about the question here? Or what could you sort of summarize from that question? Like, what is it directing you to do?
It's directing you to find the difference from her inheritance to what she needs.
Like, right. So she does not have enough there. Okay. But we don't know. It's some amount here that she has. So we need to figure out the cost of each farm, the cost of the kiwi, and the cost of the lettuce. So the kiwi is $10,000 to start, and then hang on just a second, please.
No problem.
All right, I'm back.
Hi.
Sorry about that. It was unexpected interruptions. So we'll just extend the time as long as we need.
Okay.
Did you get down the cost of the kiwi crop?
Oh. No, I didn't.
Okay, so it's 2,000 and then 4,000, and those are the costs for the 13 years. And this is where it's like, oh, I need a calculator, and like, I mean, you kind of do, kind of don't, but I mean, I don't care if you use a calculator. You have to be able to write down these equations. These are the fixed. This is the fixed cost slash startup cost. Those are two names that you might see. This is the variable slash operational. You know, what does it take to operate the business for a year, and get these numbers. So
I can do it without a calculator.
so 8,000 times 13 is 8,000 times 10. That's 80,000. Plus 3 times 8, that's 24,000. Okay, so that's 104,000 plus that's 114,000 for the kiwi.
Isn't it 104,000?
Plus the 10,000.
Oh, plus the 10,000.
Yeah, plus the 10,000.
Okay, I did that without a calculator.
Great.
So
4,000 times 13 is like 4 times 13. That's 52. Plus the zero. So that's 2,000 plus 52,000. It's 54,000. So again, the more you can do without writing down, you know, the better. Now I know you want to add these up, like that's the thing. But if you think about, okay, I'm going to subtract 120,000. If you do this first, you get smaller numbers rather than get a big number and subtract a big number. Small number added to a semi-large number. This is negative 6,000. Gives you the 48,000. I shouldn't even have written that down. I should have just gone right over here and circled letter B for that.
Oh, you just minus subtracted the.
Yes. So there's a way to work with numbers where you don't need the calculator. You don't even, it slows you down. I'm not saying this one probably would be a calculator question, but I changed the numbers a little bit on it. Let me give.
Sorry, why do you only, so you just subtracted the 120,000 from the 114,000?
Yeah, because the inheritance money isn't for both, or isn't. It's not like you get it for each farm. It's you get a one-time inheritance.
Got you. Okay. So you only need to do it. Okay.
Yeah. So let's see if we can find one here that's somewhat reasonable here. Okay, so let's do this 25. Okay, this is the same thing, just different numbers. Cost of starting a pomegranate crop in Colorado includes a fixed cost of 5,000 and an operational cost of $500 per year. Startup of a shallot crop in Florida includes a startup cost of $2,000 and a variable cost of $3,000 per year. Alyssa has always wanted to try her hand at farming, and she received this much in inheritance. So again, you want to be able to write the fixed plus the variable cost or operational cost, but you almost want to do it with all the numbers. It's 500 times 12. And the cost of the shallot crop, I don't even know what a shallot is 2,000 plus 3,000 times 12. So I had to get those two numbers.
Okay, so then 2,000 plus 3. Okay. So then you do 500 times 12. Okay. 0, 0, 0, 9. Wait, is that the answer? Negative 45,000?
No, that's the
These are the numbers you got, 21,000 and 3,000.
yeah. So I'm sorry, it's 11,000. I wrote the wrong number. 11,000.
Yeah, I was like, I got 11,000.
Yeah, because I started looking at the solution and I was like, this is not right. And then I realized because
well, I didn't get 3,800 either.
So this is 36,000. 3 times 12 is 36. Put the zeros on, and then add 2,000 to that is 38.
So that's 0, 0, 0, 6, and then 0, 0, 0, 3. I got 9,000. Not 9,000, 90,000.
For what? For which one?
For, no, wait, no. What did I get? 0, 0, 0. Yeah, I got 9,000 for 3,000 times 12.
Well, I mean, 3 times 12 is 36, and then you just take the zeros and move them with your answer.
Oh, did I do this wrong? I'm so confused. 0, 0, 0. 3 times 2 is 6, and then 0. 1, 2, 3. Oh, forgot a 0. Okay.
Great. So now this is a case where, like in the previous problem, I said we'll subtract it from one of them because it's large. Here it's better to add because you get a number that's close to this 49,000 when you add these. And then it's like, okay, well, what do you need to get back to that?
So you add 11,000 plus 38,000 and then
Yeah.
Okay.
It's like saying I have 4, 7, and minus 12. It's better to add these to get to 11 and then subtract the 12.
But if you already have a big enough number like the previous problem, you don't need to.
Yeah, like it's managing the numbers, and this is a skill they don't really teach, but it's needed to do these faster, is to make these comparisons. So that you should get 3,500 for that. Do you want to do one more of these or move on?
Oh, I think we can move on.
Okay. All right, so back to the test here. Don't think we've done anything with 30, 60, 90 triangles yet. They are emphasized pretty heavily, in everything I've seen over the years. So this is not a 30, 60, 90 triangle, but it's a kite that has, it's a quadrilateral, but it happens to be a kite. Of this. So if the length of RS is here, that's 16. And they want to know what is the area of the given quadrilateral here. Now, there's a couple of ways to do this. To find the area of a quadrilateral, there's the formula, which you may or may not know, which is 1/2 diagonal 1 times diagonal 2. That's the area of a quadrilateral. And this is a really useful one. Like it works for a square, it works for a rectangle. That's D1, that's D2, D1, D2. It also works for this one here as well. So D is diagonal, like this is a diagonal, SU, and RT is a diagonal. But I mentioned 30, 69 triangles because this one has a couple of 30, 69 triangles in it and 45, 45, 90 triangles in it. This top one here is a 30, 60, 90 triangle. Do you remember these from?
Yes.
Okay. This is the short leg over here. How does the short leg relate to the hypotenuse?
It's I don't remember.
All right, so let me just briefly divert from
Well, are we doing like cosine, like that kind of stuff?
No, it's much simpler than that. But let me show you some stuff that I've been working on here that I think you'll appreciate. So if you come to the same website where you scheduled, if you can see my screen, I reshared. I'm adding a bunch of reference sheets and other things that you might need. The 30, 60, 90 is not up here, unfortunately, but it would give you the reference that you need for this problem. And a lot of these are geared towards SAT, ACT stuff. So let me actually just draw it for you. I thought it was up here, but it's not today. I'll get that uploaded shortly. So in the 30, 60, 90 triangle, the short leg is x, the hypotenuse is 2x, and the long leg is x root 3.
Oh yeah, I remember these.
Okay, so that's how you know, oh, this is 8, and then this is 8 square root 3. Well, if SV is 8, what is VU?
Also 8.
And how about VT?
8. No.
Yes, 8.
8 to 3. Oh.
Because these are the same. Those are congruent signs. Okay.
Right.
All right. So I mentioned this formula, and that's what the solution uses. But let's say you didn't know this formula. What's the area of two triangles because these are the same. The top and bottom are the same.
1/2 BH, right?
But if you have two of them, it becomes just base times height. So the area of this whole thing is this triangle down here coming up there, and this triangle on the bottom coming up here. Do you follow that?
Yeah, because on the bottom it's just a reflection of the top.
So the area, so let's call this one big A and this big B. The area of A is 8 times 8, which is 64. What's the area of B? Well, its base is 8 square root 3. And what is its height?
8.
8 as well. That's 64 square root 3. So which of these is correct over here?
B.
B.
Okay.
Let's do another one like that. 25, question 25.
Okay.
And what did I give you? 25. Okay. All right. So let's do. All right. So this one's a little more difficult, but it's the same sort of setup here. All right. Okay. So if the length of FG, that's this one, is 16 square root of 3, what is the area of the given polygon FGHI? So again, you want to find this leg over here, you want to find these other values, and you're really finding the area of two triangles. You know, this one here and this one there, because you're moving it sort of there and there.
Okay. So here it would be 16 root 3. Would half of 16 root 3 just be 8 root 3 because you?
Yes, exactly. Now this over here is the one you multiply the short leg by square root of 3.
So do they root 3s just cancel out then?
They don't cancel. It does go away. Like it becomes square root of 9, which is 3. So you're effectively multiplying this number by 3.
Okay. So then multiply 16. This triangle is here. so then you multiply 16 root 3 times 24.
It's base times height, right? So the base is 24 and the height is 8 square root 3. And then the other one is 8 square root 3, 8 square root 3.
But do you have to multiply that by all by 2 because it's
No, so like the it's a square, ends up being a square. The area of a square is base times the height, and they just happen to be the same. If you did a half here, you would have to add the other half, which would be the same thing, and that's why you just keep like a half of A plus a half of A equals a whole A.
So that would be 6 or 64 times 3, right? Which is, I don't know.
192.
192.
And then this is another good one. So 8 times 20 is 160. 8 times 4 is 32. So that's 192 square root 3.
Wait, what? Where'd you get the 160 from?
8 times 20 gives you the 160. 8 times 4 gives you the 32. Yeah, you always break these numbers apart. I know that they teach you this, but that's not. I mean, that works great if you're 5 or 6 or whenever you do this. But we need a faster way. I mean, this is a timed examination.
Yeah, that's my go-to right there.
Yeah. Okay, let's do a little bit on 30, 60, 90 triangles to close out here, because this is such an important thing. This is x, and x is always crossing 30 degrees. This is 2x, and this is 60 degrees, x squared root 3. What I'm hoping you will see is that this relationship, like you double the hypotenuse is double the short leg, and then the long leg is square root of 3 times that. What ends up happening though is you end up getting problems that are much more difficult. Like they'll tell you that this is 9, and they want you to find x and y. And I'm skipping through a lot of the intermediate sort of steps. And this is 30. You set the x root 3 equal to 9 to solve this. Do you remember doing that?
Yeah.
Okay. And this is where you got to say, okay, well, I got to divide both sides by square root of 3. Do you recall how to rationalize this?
Don't you have to multiply by root 3 on the bottom top?
Yeah. Which is 9 square root 3.
I remember I like doing the rationalization. Okay. Yeah.
So what is this 3 square root 3? Because it's not x. It's this reference x. What does the reference x refer to? What does this mean down here? It's the short leg. So which over on the right is the short leg?
The y.
Yes. So this is 3 square root 3 here. Even though we wrote it for x, even though that's x, like there this.
Right, because it's the one across from the 30.
Exactly. So now you asked me this earlier. To find the hypotenuse, we could write formulas, but it's double. And when you double this thing, you're doubling the
9.
number on the outside. So it's 6 square root 3. Double, not square, double, yeah.
Okay.
Okay, so let's do another one here. Again, these can come in different orientations, so you have to be really comfortable. Like that's 30, and that means that this is 60, and this is we'll call this a 24 square root 6. And I want you to find x and y.
So that's double. So it's the short side would be, well, the x would be 12. No, not 12. Yeah, 12 root 6.
So is that x or y though over here on the left?
No. It's y.
That's right. It's very confusing, but that's how these problems are written. Now it's always better to do it in words. The long leg is the short leg times the square root of 3.
Right. So it's 12 root 6 times square root of 3.
Yes. And then this is where you can get some more issues. Like, okay, well, it's 12 square root 18. Great. Do you recall how to break this apart?
So it'd be 3 root 2.
So it's 12 times 3 square root 2, which is 36 square root 2.
Okay, I remember this.
Okay, so here's the problem. This is in like every SAT ACT prep book I've ever seen. They don't, or I mean, they'll give you a variation on this, but in a hexagon contains 6 equilateral triangles. And you may not know this, but you will now, is that that's a 60 and a 60 degree there. If you cut these in half, guess what kind of triangle you get?
30, 60, 90.
Right. So what they'll do is they'll tell you, what if the base is 12? Like that's a 12 right there. That means this is 6 because it's half the base. And they'll say, what is the area of the hexagon? And all you have to do is find the area of one of these big triangles times 6, or one of these triangles, and then double it. And you have to find the the long leg here. If they give you the short leg, the long leg is 6 square root 3.
And then the hypotenuse is 12. Oh, what? They give you hypotenuse.
No, well, yeah, because it's an equilateral triangle. But what's cool is that you can figure, okay, the area of this triangle is 1/2 6 times 6 root 3. Okay, that one right there. But if I want the whole thing, I just double it, and that gets rid of that half. So that's 36 root 3 for one of these. And then if I got 6 of them, that's 6 times 3 is 180 plus the 36 square root 3, so it becomes 216 square root 3. So that's where you start making
the connection.
Yeah, the connection. Like I don't know what they're going to give you on this test. They could give you any of these, but you got to know 30, 60, 90 triangles.
Yeah, that's a good shortcut right there.
Yeah. Okay. Do you feel like we've satisfied the time today?
Yes.
Great. Okay. Thanks for scheduling. Oh, go ahead.
Oh, sorry. You do tutoring for like calculus, right?
Of course. Yeah.
Yeah. Okay. I'm going to take calculus AB next year. So.
Great. Yeah. I help a lot of students into graduate school with math. So whatever you need.
Okay. Thank you.
I'll be able to help. Yep. I'll see you next time. Have a good day.